So this is one strand, this is the other. When you open the DNA with temperature, this.
We are so good at going off topic. We should win a prize.
So what's so interesting about this is like we're doing sort of coverage.
So we're going to do a simple DNA extraction, PCR, and running a gel with the gene for blood group to show we can just isolate that specific gene successfully. Okay. To get the DNA, we'll be doing a cheek swab. So we just take 10 mils of water, vigorous cheek chewing, and swishing. Make it bleed. We put the samples in the centrifuge to get the solid cheek matter down to the bottom of the tube, and then we can throw away the water.
These are old vintage centrifuges that we're very proud of.
Where is it balanced? Oh shit! Sorry.
Oh
fuck! Man.
You didn't balance it, did you?
No, I forgot to balance it. Sorry. Is that leaked or is there still some in there?
No, there's still some in there.
Okay.
Okay, go. Take her away.
That's better.
Has everyone seen my astronomy program, by the way?
No, it looks cool though.
Yes, it's called Celestia. It's a free download. It's crushed. Look, that is gorgeous, man. That is fucking
It's
brilliant.
really good. Yeah, downloading it now. It's great.
I think you need quite a lot of RAM.
Space tourism. Right, that's 5 minutes. So we'll stop it. It's Louis.
Okay.
Simon, have a look if you've got a pellet. I've got a pellet. Simon, I don't think you'll be able to see it. I know, I can see you got one. You got one?
I think I do, yeah. But can we try and...
It should look like that.
Oh,
Oh yes, I've got quite a tight there.
See if you can get anything out, like, so you'll find out soon enough. You probably just didn't swish hard enough. Okay, so everyone take a tube and a Pasteur pipette and try and get your pellet into the little tube.
Oh, success. Oh yes.
There's a happy man with his pellet.
that is your DNA?
Well, it's just the inside of his cheek,
Okay.
which includes the DNA.
The inside of my chip, the DNA is also inside the cell nuclei.
Yeah.
Yeah, so we've got to extract it first.
There's lots of other stuff apart from DNA in there.
Yes.
Most of it useless.
Like what?
Which we don't
Well,
want.
it's just your cheek basically, so it's cells. It's just a collection of cells. So the DNA hasn't actually been extracted yet. Are we ready for the next step?
Yes.
Okay, next step we add Chelex beads, which I don't fucking know what they do.
Right, so Chelex is a proprietary reagent, I suppose. It gets rid of any of the stuff which we're not interested in the mix. So it gets rid of the enzymes in your saliva, the cell membrane, the nuclear membrane, whatever else is in a cell, and just allows us to get access to the DNA.
This is a mixture of my cheek cells plus Chelex. And once they're mixed, we're going to boil it, which will lyse the cells, release the DNA, and the Chelex will prevent anything but the DNA from getting into solution.
Oh, what's that noise?
That's the thermal cycle again.
That's the most like
Oh, you want the noise?
hacker-looking thing of the in the place.
Should I shut it down? You want the noise?
Yeah, and also the we want that in shot. Don't we?
So we're using our thermal cycler, which is just going to keep it at 100 degrees. So we'll just turn it on.
Right.
Put it in.
So if someone didn't have one of these,
You can just put it in boiling water, which has exactly the same effect. Okay, so we do this for 10 minutes.
We put it on gloves.
Is it a sort of talisman that means nothing?
See, if we want to actually get a license, we have to do certain things. And one of the things we have to do is, for certain procedures, we have to wear lab coats. Some of the procedures we have to wear gloves. Yeah. So I think it's quite good to get into best practice now. Even though, as Will says, it's probably just a talisman. It's probably just ritual. As an anthropologist, you'd like that kind of thing.
These have just come out of the 100 degrees C incubation, so the DNA should be floating around in here now. So what we're going to do now is just put it in the centrifuge quickly to put all the solid at the bottom, leaving only the liquid at the top, and the liquid's what we want because the DNA is dissolved within it. The clear bit at the top is hopefully water with our DNA dissolved in it. We're now just going to take 200 microliters of that water and keep it, and then throw the rest away.
Right, we're going to carry out something called a polymerase chain reaction. The polymerase chain reaction involves using primers which zero in on the particular piece of DNA we're interested in. At 96 degrees centigrade, the DNA strand will split apart. You have the primers here, they attach to the beginning of the DNA, and the polymerase extends the DNA right to the end of the genome, so you're getting a duplicate of the DNA strand. We then cool it down again, we heat it up again to 96 degrees centigrade. The primers attach again. It will only go to the place where the last primer was. It'll only duplicate the gene we're interested in. We then cool it down again. We heat it up again. Cool it down again. We heat it up again. We do this many times. So at the end of the actual process, we end up with literally millions and millions of copies of the gene we're interested in. And that's basically how PCR works. Yes?
PCR has got certain ingredients. You've got the template, which is the DNA we've got dissolved. Then you've got primers, which are what actually isolates each end of the DNA sequence you want to get. You've got Taq polymerase, which actually amplifies the bit you want to get, so we get lots of it. And then there's just water for dilution. So you're going to add the water first. I think my hand's actually going to be in the way. 2.5 microliters.
Yes.
That's what I mean. It's a Taq ready mix. So we put in 12.5 microliters of each of these. So when it's not in use, it should go nice. So we're just going to start the PCR reaction, which will take about 2 hours. Alright, there we go. So I'm going to add 15 microliters of each sample. And I'm going to add it to 3 microliters of loading buffer, which is in here already. And then take another 15 of that and put it in the gel.
It hasn't got any settings. That's just like
Okay.
it's just like you plug it in. So this is okay. That's a good idea. I think we should. Yes, I do it.
Do you have any idea what the current was on the other one?
No idea. We've never measured it.
And now we're going to add the DNA extractions that have not gone through PCR. This is the gDNA, so it's just
Genomic DNA.
genomic DNA. It hasn't gone through PCR.
It's the full gem.
Okay, gel's ready. So now we just hook up the power. DNA migrates towards the positive. Yeah, it's bubbling well. Everyone put some goggles. Could you turn off the light?
I can see the I can see the face of God here. I can see
This is really quite strange. Nothing. I know. Wait. Maybe. Actually, no. I think it's all failed.
Oh dear.
another afternoon of my life. Another 5 hours of our lives wasted.
So, I guess probably some pipetting mistake. We might try PCR again on those same extractions because there seems to be a good amount of genomic DNA there. Yeah.
I'd like to be more rigorous about doing it. Okay. I find this kind of thing very disappointing. I think we'd like to. I'd like to make this. I'd like to sort of carry out some. I wish. Shut the fuck up outside, will you?
It is the worst sound in the world, though. He's cutting a radio in half. I think that may have not been filmed very well.